Hey everybody, and welcome to tutorial number 4. In the background today we see the Brooklyn Torch, which is the local currency of North Brooklyn. You can use it to buy goods and pay for services. It's accepted in some cafes and restaurants, and it's money specifically for that community, only honored within that community, and so it keeps money within the community. And it's a great idea, and more neighborhoods in Brooklyn should do this, should have a local currency, I believe. And of course it's a lovely design with the cat, the dog, and the squirrel. So today's Mac's work, we're going to be looking at the $ argument, laying out objects on a grid, select object, greater than, less than objects, the split object, which is a very useful object, and also finally we're going to look at the autopattr and pattern storage structure that's been sitting in our patches throughout the last 3 tutorials and we haven't used at all. So today we're going to actually dig into that a little bit. So first of all, laying objects out on a grid is very important, very useful. Lots of cases where you want to do it, and as I've pointed out in the previous tutorials, ordinarily one would do this using jit.gl.multiple and a matrix containing coordinates, but we're not actually covering matrix yet in my Brooklyn College class, so we're going to look at different approaches to it and get into matrix later on in the tutorial series. So the first thing to do when thinking about how to lay out objects on a grid is to lay them out on a line. And this should be familiar from the last tutorial. We can take an Uzi 100. We can use the output of the Uzi to set the target. And here is where I'm going to show you the first use of the $ argument. We've been using pack target I so far because I didn't want to show you too many things at once. We already needed the pack object for something else, so we used it in this case as well. But really, we can use a message box here. And that message box can have in it target space $1. And what this $1 is a changeable argument that is replaced by whatever comes into the message box. So these two things here are exactly equivalent. Let's take a look at them. All right, so pack puts things together into a list, puts the word target and the incoming integer together into a list. Whatever number I put in becomes target that number. The changeable argument in the message box, the $1, means the first element of the incoming list will occupy this position in the outgoing list, which in this case has exactly the same meaning. If I send a 108 in, I get the message target 108 out. So this is just a little bit more compact way to handle the same thing that pack does. And we'll see it applies in a lot of cases and just generally makes life easier and makes your patches tidier. So target space $1. And then to spread these things out throughout space, we can just use a simple scale. We've got 1 to 100 coming in, and we can say -15 to 15 going out. And here we can use this this changeable argument again. First I'll do it the pack way, because that's the way you're familiar with pack, right? Position, and then a floating point changeable x position 0y 0z. Here's that same thing with $1. It's position $1 0 0. So you see these two are exactly equivalent. The thing that's going to change is the x. The difference is with this one, with the pack position, I need to be careful about which inlet I send my data to, but with the message box, I don't. I send it to the left inlet, and then it will go wherever the $1 is. Let's take a look at it into a message box again so you can really see what this does. I send in 11, and it says position 1100 because the $1 is replaced by the value coming in. So we should be able to just lay out our 100 objects all next to each other. Great, we've done that. So how do we get these into columns? Right, we've got them laid out on a row, but that's not what we want. We want them laid out in a grid. So how's that going to work? Well, the first thing we want to do is arrange our column spacing. Let's say we want 20 columns. Now I still have 100 objects, so I still need to use my right counter outlet of Uzi to address each of the 100 objects individually. But I'm going to address them in groups of 20. I'm going to count from 1 to 20. So this is going to break my 100 objects into 5 groups. So there'll be 1 through 20, and then it'll repeat. There'll be a second number 1, a second number 2, a second number 3, and there'll be a third and a fourth and a fifth. There'll be 5 groups of 20. And those are what I'm going to lay out over this same space. So now you're seeing something quite different. You're still seeing 100 objects, but there's 5 objects here in this first position, 5 objects in the second position, 5 objects in the third, fourth, fifth, sixth, etc. Right? Because I'm using 2 separate counters. I'm using the built-in counter of Uzi to individually address all 100 objects, but I am only positioning them in 20 different possible positions. So great, that works. Now how do I spread them out in space? Well, this is an interesting thing. There's a lot of solutions to this. There's probably about 6 different ways to handle grid layout before you even get into dealing with matrices. And I'll show you one that actually doesn't work first because it's kind of interesting. If we don't know how to take these objects and lay them out into a grid, we can start with just by laying them out randomly. And I'm going to scale them. It's going to be from 0 to 5. So I'm not really sure how to make a proper grid out of these yet, but I know that by doing something with the Z value, and it's also, you should notice here, we're looking from the top. Ordinarily we look from the front, but for today we're looking from the top. So my camera is at Y 44 meters looking down on this. So any change I make in laying these out vertically on the screen is going to be a change in Z. And I'm going to switch this back to the familiar pack format, because we're dealing with 2 floating point values, and I don't want to introduce how to do that in the message box yet. And it's interesting right off the bat, right? Because I'm getting things laid out in an orderly fashion horizontally, laid out in a random fashion vertically. And there's 2 reasons why I show you that. One, because it kind of helps us get the gist of the problem that we've got to solve by doing something on the z-axis and seeing it work. It also is visually nice. It like sort of immediately and easily gives us something that sort of looks language-like or looks, you know, data-like. It's or maybe abacus-like. It's kind of a nice little simple generative thing to do. So our theory here is we've got to do something on the z-axis. and maybe we're not sure exactly what it is. Well, I'll show you one solution that I like, which is the solution of using integer division. So first of all, let's take a look at what that means. If I take a number and divide it, say I'm going to divide some number by 10. Okay. We ordinarily think in floating point terms. 10 divided by 10 is 1. 5 divided by 10 is 0.5. 1 divided by 10 is 0.1. But there's also integer math, where we take the floating point out. And then we get different answers. 5 divided by 10 integer is 0, meaning there are 0 tens that will go into 5. Similarly, 8 divided by 10 is 0, because there are no tens that will go into 8. But 10 divided by 10 is 1 in both cases. However, 14 divided by 10 is 1.4 in floating point math, but it's only 1 in integer math, because only 1/10 wholly goes into 14. So you can think of integer math as chopping off the floating point component, or ignoring the remainder of division, and that's exactly what we want to use here to divide us into rows. We want to take the count, the target number, and divide it by, in this case, 20, because our rows are 20 items long. So every 20 items we want to move to a new row. And in this case, we'll be scaling from 0, row 0, to, 5. It'll be 5. There'll be 5 rows. Minus 10 to 10. And then we get everything laid out nicely on a grid. Oops, except for this. What's that critter doing there? And this is the kind of thing that happens when you have mismatched numbering systems, zero-based systems and one-based systems. And it just crops up in computing all the time. Some things are zero-based, some things are one-based. Uzi happens to be one-based, which usually plays very nice with poly, which also happens to be one-based because 0 is the special case. However, grid math happens to be zero-based. In other words, the first row of our grid is row 0. So we need to move into a zero-based situation, which we could do just by subtracting 0, subtracting 1 from the counter output of our Uzi, which means the first object addressed by the Uzi is target 1, but its number is 0. And we can change this counter to match that too, just so our Uzi is functioning totally in a zero-based. And this is actually 0 through 19. And that fixes that problem. So now we're laying stuff out on a grid, and it's a grid that we can make any kind of alteration we want to. And one of the things I want to do at this point is see all these other inputs on the scale object here. These we can address these with number boxes, and thereby make adjustments. Now they're not. This is not going to be like an attrui. These values are not going to populate up into the number boxes for us, but they do allow us to try things out without having to retype the scale object. So what if I want to do negative 15 to 15 and try it again? Oh, wrong inlets, pardon me. There's a sixth inlet of scale that we're not using. I'm just setting the, I'm replacing these two values, the -10 and the 10, which are the fourth and fifth inlets. So I'm going from -15 or -16 to 16. And if I want to compress that range, I could say, okay, -8 to 8, and fire it again. And you can see I can change these values dynamically. In fact, I can even hook them up to the button so that as I change them, I can see it happening. And I can hook this up to any aspect. For instance, my X. Now I'm from -20 to 20. And notice they don't change inside the object boxes. They only change out here in the patch. And for instance, my number of columns I can change. And so the right inlet of my divide will be set by this number box. And of course, the counter then needs to be set to 1 less. So I'm going to use that -1 object again, very handy, the -1. And then to set the counter maximum is one of these inlets here. There it is, set count maximum, the rightmost inlet. So if I want 10 columns of 10, now I have columns of 10. If I want columns of 3, now I have columns of 3. If I want columns of 11, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11. Great. Columns of 21. Or back to our columns of 20 as before. So these things can be changed, and then we're going to look at later on today how we can save these settings. It also, when patches start to get like this, it's really important to start commenting them. Number of columns. Width. And height. Call it grid. Grid height and grid width, and we'll call this one build grid. Okay, so that's gridding, and we've discussed the $1 argument. So now let's look at some other stuff. What else can we do with this grid? Well, what I was playing with earlier and really having fun with was kind of building mazes, not necessarily solvable mazes, but sort of, mazes as graphic devices. So for that, I took an Uzi and set all of these to cubes. Kind of walls, made them into walls. So maybe a trying to look at my notes to see what I did before. Let's see how this works. Set all of these too. Yeah, walls, nicely. Okay. So they're walls, and then they can have a random rotation, and that'll sort of make an insta maze. So I'll go through all 100 of them, and each one will have a random rotation of either 0 or 90 degrees. So my random objects can give me a response of 0 or 1. 0 times 90 is 0, so unrotated. 1 times 90 is 90, so rotated. And then I can use my new toy, the $ argument, to say rotate x, y, z, $1, 0, 0 in a message box. And of course I also need to target, and I can just glom onto my old targeter there. And that doesn't work at all. Let's see why not. Ah, yes, wrong inlet. I'm sending this to the texture inlet. Send it over here. Ooh, I should teach you send and receive too. Ooh, am I rotating on the wrong axis? It looks great. I love it. But I feel like it's the wrong axial rotation. It is. Well, great. I'm going to keep this in mind for later because I like the way it looks, but then realize that I'm rotating on the wrong axis. So let me reset all these rotations back to 0. 0, 0, 0. Okay, and what axis do I want to rotate? I'm looking down from the top. So I want to rotate on the y-axis. So now my $1 is in the y position, right? And now I have something that's going to possibly get maze-like if I shrink my grid size down here. Yeah. Okay. I mean, it's not a maze, but it's somewhat maze-like or labyrinth-like. I'm gonna add some more. I'm gonna go up to 200 objects here, just by increasing my Uzi and increasing my poly. It's gonna take a moment for the poly to render and catch up, or Max is just gonna crash, which sometimes happens. All right, let's just restart Max. This is another problem that is solved by using jit.gl.multiple, is that there's a bit more efficiency in the way that multiple objects seem to be handled, because you can really make a ton of objects using jit.gl.multiple, and you're really limited to a couple hundred in any given poly scenario. But we should be able to get 200 objects here. That should not be a trick. Yep, seems happy. And we'll build our grid again. And now we have 200. Cool. And we'll change our grid height again. -5 to 5. Rebuild the grid. And build the maze or the labyrinth on all 200. Lovely. So we're getting like a random maze or labyrinth or visual composition, however you want to think about it, each time we click the Uzi. So just as a brief digression, let me show you send and receive, because when you get long patch cables like this across your patch, it starts to get hard to see things. So I like to, and most Macs users like to, create wireless connections between things. And we do that with the send object. And this creates a wireless connection. I'm sending everything that comes out of the right outlet of Uzi to a destination called Uzi counter. And I'm sending everything that comes out of my rotate XYZ message here to a destination called to_poly1. And then I create corresponding receive objects. Receive to poly1. And I can actually, we'll call this to target instead. Send to target, and over here I'll have a receive to target. I also like to color code my sends and receives so I can see them, because the nice thing about the patch cord connection is that you can see it. The bad thing about the patch cord connection is it starts to make your patch messy. So so if you color code your send and receive pairs, you can see them. There we go. So it's exactly the same as having connected them with patch cords. Send and receive. Except there's no right to leftness in send and receive. So you have to see here it's safe because I know the right outlet of my Uzi is going to fire first before the left outlet of my Uzi. So I know that my target's always going to arrive before the data. But when there's right to leftness ambiguity, you do need to use a trigger object, which we looked at briefly in class. We haven't talked about it in the tutorials yet. You do need to use a trigger object to ensure right to leftness. All right, so let's move on to the next topic, which is, so in a simple scenario, it's actually not really the next topic. It's a continuation of what we were doing here with the grid height, grid width, number of columns, build the grid. As you start to create more and more variations on things, you're going to want to be able to make adjustments to those variations and then go back to previous versions. Because right now, we've been building things so far that are static. Once you've built them, they can only operate in one mode. But of course, we're working with computers, so being multimodal is the name of the game. We really want to be able to move between states. So let's try something a little different here. Let's try a random 3 and give ourselves another rotational possibility, like 45 degrees. Ooh, that's interesting. I'm liking that. And then, in addition to that, why don't we give some random scaling to these objects? So do maybe 5 different scales, and we'll say from 0.3 up to 2, and apply that to the width of the object. And again, we're going to we're changing gears here. Instead of using pack, we're going to use the changeable argument of scale. And I'll make the changeable one the x. And see, that's going to the send object too, which is the same as making this connection all the way over there. I'm just sending all of this stuff through this invisible patch cord to the receive, which arrives at the poly. And look at how interesting this variation is. I have random rotation either 0 degrees, 45 degrees, or 90 degrees. And I have 5 choices of random scale, from 0.3 meters at the smallest to 2 meters at the largest. And you know, it's looking really interesting. It's looking cool, so I want to be able to play with it and make changes. Ooh, you know, like that. What happens if I go like that? Really nice. But I want to be able to get back to something I had before. And that is where our autopattr and pattern storage come in. So the fact that I'm choosing 3 angles is something I can change. The fact that my angles are 45 degrees is something I can change. The fact that I'm choosing 5 different possible lengths is something I can change. And what the range of those lengths is also something I can change. So I'm hooking up number boxes to all of these things to make them changeable, and commenting them because the patch is starting to get messy. Number of lengths, number of rotations, degrees of rotation, min, max length, and total bonus points to anybody who can see the really important thing I haven't done here yet. Pause it, because I'm about to give it away if you want to search for it yourself. Ready? Okay, here it is. So I'm randomly choosing between 5 different lengths. But if I change this and randomly choose between 10 different lengths, there's another value that has to change, which is this 4, right? Because I'm no longer scaling 0 to 4. I'm now scaling 0 to 9. It would still work, but it wouldn't necessarily work as expected. So this is another one of those other great places to use -1. -1 just shows up a lot. -1 into here. The 0 stays the same because random always starts with 0. So that fixes my number of lengths. So let's try 10 different lengths from 0.1 to 10, and 5 different rotations of 10 degrees each. Wow! Something totally different. And I don't actually like it much, but fiddle around with it till I find something that maybe I do like. That's getting interesting. I like that. All right, so here I no longer want to use the message box. I'm going to use the pack because I want to also be able to adjust the width of these things. So pack scale of some floating point value 1 and some other floating point value. I'll put it in here as like 0.1 as default. We haven't talked about that, so I'll just put in some floating point value. That's fine. Which I will set to 0.1. Okay, I like this. So if I like this, how can I save it? And that takes us up here to our store buttons. Before we do anything else, autopattr and pattern storage, what they do is they connect to any user interface object on the screen. So in this case, it's going to be all of these number boxes we created are going to automatically be indexed and stored in this autopattr storage combo. But sometimes the connection gets broken. So what I'm going to ask you to do before you use it the first time is just retype any letter, like delete the R, retype the R. That's going to reinstantiate the object and make sure everything is connected. And to see if it's connected, you can double click the pattern storage, and you'll see all of the number boxes in your patch listed in here. And you'll see their current values. You don't have to deal with this, but you can just double click the pattern storage just to see that everything's in there. So once you have a set of settings that you like, you simply hit store 1. And now you can get back to that. So let's build something else. Let's build something, let's make a really narrow grid. And change our rotational choices. And change the width of these. And I've got, again, now I've got something else really neat and interesting looking that's totally different from what I had before. And so I'm going to store that as 2. And when I want to go back to something, I simply send that number to pattern storage. So I can say go back to 1. And now I'll get style number 1. Now I can go back to 2, and I get style number 2. Back to 1, style number 1. Now it doesn't save my attribute, so my camera doesn't jump. My camera would only jump if I used number boxes into a pack. And is everything saving properly? I believe it is. So you can make as many of these as you want, and you don't actually have to create a new store button each time, because now that we know changeable arguments and we know the right inlet of the message box, we can simply put a number box here and say store $1 message into the right inlet of this message box. And then we want to give this message box a color to be like, okay, this is our real like active live saving button. So if we want to store something into number 3, we send a 3 into the store $1 message into the right inlet of this message box, and this becomes the store 3 button. And let's find a nice. Let's go back to number 2, because number 2 is an interesting starting place, and we'll modify it. We'll give it a 3rd rotation. See if we like it. Sure, I like it. It's interesting. So I will store that as 3. And just for good measure, let's do one more. Maybe something that has kind of shorter lengths to it. Oh, wow, yeah, that looks like a language. And maybe spread it out on the grid a bit more. Whoops, that didn't work very well. Oh, number of columns got knocked down to 0. Let's build it back up to 20. There we go. And we'll store this one as number 4. Store 4. Great. And so now I can go through all of those, and I can make message boxes for them if I want, so that I just have a button for each state that I want. State 1, state 2, state 3, state 4. Let's try that out. So here's state 1, good. State 2, great. State 3, cool. State 4, nice. So I can always get back to these. Now here's the interesting thing. Now when I save and close my patch, there's going to be another file called storage that holds all of this information. So I'll just close it, and you'll see it wants me to save storage somewhere. And I'll save it in the same folder as my patchers. But I'm actually going to cancel this because, oh, I just lost it. You can't cancel it. That's unfortunate. Okay, so let's see, what else do we have to get to in this tutorial? 20 columns, grid width of, yeah, they did not save. That's unfortunate. But no sense in crying over spilled milk. Just make some more. I like that one, so I'm going to store that as number 1. And I'll make something with just 2 rotational choices. Ooh, I like it. Wow, totally new, totally different, very maze-like. I'll store that as number 2. And something with maybe some more length choices and can get longer. Maybe fewer length choices. I'm not really excited by it, but I'll save it. That's number 3, and let's just get a 4th one as well. Give myself an additional 2 more rotational choices. Maybe 30 degrees each. Nah, that's not very interesting. What if I narrow down the number of lengths? Better. How about this? Now that's really good looking, so I will make that number 4, and now I can switch back and forth between these. Number 1, number 2, number 3, number 4, and these looks are stored in the pattern storage so that, as I said before, when I close the patch, it asks me to store, and I hit save, and that's going to save all of my data. All right, so just a few more things to look at here. Let's get started up again. And see what I did there? I used my stored information to take me back to this look. So what if I want to make number 100 red, for instance? You know, there's not really, I mean, I could certainly do that. I could certainly just say target 100 GL underscore color 1001. That's, I'm targeting an individual and changing it red, and there's number 100 right there. But there's another way to build that into the process where one object gets treated differently, and that is the select object. So here, all of my objects, for instance, are getting a random choice between these 2 rotations. What if I wanted there to be an exception to that? For instance, what if I wanted object 100 to have its own special rotation? I could use the select object, say select 100. So only when one object 100, number 100 passes through this object, something will happen here. Otherwise, the ordinary event will take place. But select 100 is going to have some different property. So for instance, we'll just give, 100 will always have a rotation of 55 degrees, regardless of what all other objects are doing. When it's object 100, it's going to be at 55 degrees. So see, object 100 is now fixed at 55 degrees, no matter what the rest of the objects are doing, because when the number 100 comes out of the Uzi and passes into the select, the left inlet is banged. Every other number passes out of the right. So if I want two specially treated objects, I just put another number in the box. If I want number 101 to also have a special treatment, a new outlet is added. So this is a bang if input matches 100. This is a bang if input matches 101. So I can have something totally different happen here. For instance, I can say, I can rotate on a different axis. So object 101 is going to be rotated on the x-axis. There it is. Object 101 right here is always going to be rotated on the x-axis. And we're not seeing them every time because there's the possibility that they're very short. Let's change that. So I've created some fixed points within my architecture. Object 100 is always rotated 55 degrees. Object 101 is always rotated 90 degrees. Okay, so what about a range of objects? I'm going to take object 101 out just for the sake of cleanliness. I'll leave the select in there for you to see. So what if I wanted to say, all right, every object 100 and above is going to have a different color, for instance. Well, it's actually a very similar consideration. We just say greater than 50. So that means let's do greater than 100. So objects whose number is greater than 100 will have something happen. But here's how Max answers the question of greater than 100. Let's look at it in isolation. It answers with a number, right? So when I send it 24, 24 is not greater than 100, so it returns a 0. When I send it 142, it returns a 1. 1 in this case means true or yes, and 0 means no or false. So when this condition is true, I'm going to get a 1 out of this outlet. Here's another use of the select object. Select 1, meaning press the button if and only if the answer is 1, true or yes. So here I can say GL color, and I'll make them yellow if their number is greater than 100. And the nice thing about send objects, you can put them all over the place. Unlike load bangs that you don't want too many of, sends you can use to your heart's content. And in fact, you can use send and load bang together. So now all the objects greater than 100 are colored yellow, except for the fact that now I have a right to leftness problem. Because you see, object 100 is yellow, and object 100 shouldn't be. So that indicates to me I have a right to leftness problem, which happens when you start using send and receives. So let's look at the trigger object, which is going to keep things in right to left order. I'm going to take this counter outlet of Uzi and I'm going to trigger it 3 times. The first one is the rightmost one, which is going to be sent to the target. Then the next one is going to be my color changer. Then the next one is going to be my randomizer, my rotator. Ooh, and it still doesn't solve the problem. That's pretty interesting. I'm not sure why that is. But object number 100 should be... Oh, no, we didn't, we made it red manually. I see. So if we want to make it red again, we'll need to actually give it its own GL or color 0, 0, 1. There, and now object 100 will be red and rotated in 55 degrees. Yes, quite so. Perfect. And also trigger. Trigger is also important here. All right, we're coming up on an hour. I want to get this done before an hour has passed, so we're just going to look at one more thing, which is split. And split is very similar to select, except it allows us to deal with a range. So what if we want objects 30 to 50 to have some particular property? And I'll just use color here because that is going to be quick and easy. Objects 30 through 50 are going to be a lovely blue-green. And just for the sake of spelling and grammar, there should be a button there. And they are. Just to follow up on this a little bit, and I'm going to be a little tidying action here. The numbers themselves do come out of the split object. So if I want to, I can also use a scale here and say scale from 30 to 50 is going to be from 0 to 1, for instance. And oh, while I'm at it, I can show you one more thing about the $sign argument, which is that you can use it twice. So my red is 0, my green and blue will both be whatever this number is. It's not very dramatic. I'll make, let's go 30 to 50. Make it gray. It's still not very dramatic. All right, I'll make it red. That's always easy to see. There, going from gray to red. Do 40 to 60, so it's on one row. And that pretty much does it. I'm not feeling great about this, though. Let's try 20 to 60. I'm feeling like it might not be fully working. It's an odd, yeah, it's an odd result. No, I guess that's what I'm expecting. from black to bright red. So a very straightforward grid. And you can probably see it more clearly. Yeah, absolutely. Right, from black to all the way up to red. Yeah, that is working. Right, much easier to see in the straightforward grid setting. There. Yeah, from black through to bright red. Wonderful. So thanks for your attention. And to my Brooklyn College students, your continued project this week is the maze, the graphic maze, and you got some hopefully some good ideas for that in today's tutorial. And for all of you, feel free to post questions on the YouTube channel or email me with questions. And thanks so much for watching. Bye-bye.